Hello everyone, welcome to the control system. This is part 3 of lecture 5 block diagram, and in this section uh, we'll discuss how to obtain the transfer function using MATLAB. Okay, so MATLAB has convenient commands to obtain cascaded, parallel and feedback transfer functions. And suppose that you have two components, or two transfer function G1 S and G2S, they are connected. This should be 2, alright? Sorry for that. So to obtain the transfer function of the cascaded system, parallel system, and feedback system, we can use the following commands. So if two transfer functions are connected in theory like this, you can use this command. And then you need to specify the numerator of G1, denominator of G1, numerator of G2, and denominator of G2, and the output. Okay. This is the numerator and the denominator of CS over RS. And if two transfer functions are connected in parallel, you just need to use this one. Just change this command. And if they are connected in feedback form like this, you can use the feedback command. Okay? And suppose, for example, you have G1 given like this, and G2 given like this. So in MATLAB, you can obtain CS over RS easily. You can write a script and need to specify the numerator and denominator. So now 1 is the numerator of the G1, 10. 10 is just this one. Denominator of G1 is given like this in MATLAB. So 1 is just the coefficient of this, 2 is this coefficient, and 10 is this one. The same way for G2, okay? And then you can use all of this. So let's do it in MATLAB. I need to clear all of this. Okay. So you can write in a command window or you can write a script. So we're gonna do both. So first let's do it in command window. So we need to specify the numerator and denominator of G1 and G2. So 1 equal 10. Oh, and if you don't want it to pop up like this, you can use num1 10 like this, and of course then 1 full 1 2 10. Okay, the same way for num2 equal this is 5 and then 2. I'm kind of lazy to do all of this, but I have to do it, and you have to do it too. So I need to, I've already have the transfer function. Now I need to specify, okay, this equal, I want the theory, okay, then 1 and num2, then 2. Okay, so this is numerator and denominator. This is a coefficient. If you wanna see it in terms of S, you can use this print this SYS. So you wanna indent. Okay, see, this is the transfer function that we obtain, CS over RS, when G1 and G2 are connected in theory. And you can also do the same, but change the comment for the parallel case and feedback case. So in MATLAB, you wanna go to the previous command. I mean previous what? Yeah, command or previous. I don't remember. Okay, let's go with what you have typed before. Okay, so you can change this parallel. Change this. Okay, P stand for parallel for me. You can define whatever you want, and then boom. Okay, I can also see it in ThermalVest. So num P, then P, this one. Okay, you can do it like what you did before, but feedback case, feedback, and change this to PF for feedback. All right. So when print SY has num F and then okay. This is how you do it in command window, and you can do it in MATLAB script file. Okay, create new script, save it. I have main one. Let's change different name. Oh, let's just say TF or obtain. Where is obtain TF? Okay. So clear mean clear all this variable in the workspace. So if I type clear here, boom, this gone. And CLC mean clear the command window. Okay, boom. And then I need to specify the numerator, the same as what we did before. Okay, I just typed this again. 1 to 10. To what is it? 5. Num. Okay, then 2. 1 5. Okay. So what is this? Okay. Use the brackets is unnecessary. Okay. You don't need to use the bracket, but it is not wrong. It is just unnecessary. Alright, and now again, so I should use S for theory. Use any variable that is convenient for you, and then num2, then 2. Okay. Oh, theory. And then I want to print it. Num s, and then num. What is it? P, then P. How to spell parallel? Num1, num2, then 2. Print s. P. By the way, this is not correct. Then the last one is num f. Nui or num, I don't care. F feedback, and then okay, save. No, not yet. Print F. Okay, now you can save and run very fast. Okay, this is what you get. The same way, not the same, it's the same result, but different way. But you can reuse the code later if you define like this, right? Like this. And some tip, for example, uh, if you want to run only this part, you can just use this. Okay. Let's put here. I mean, the code can only run from this. Just click on this point. Okay, and you run. See, it's only run to this section, and it stop. Not stop. It just stop. And you can continue. But in this case, if you want to check the value, you can see. Put the cursor on that too. You can see the value. It said that it's 1 by 2 matrix and it's double with the data 1 to 5. Will show you the value. Well, this is not so useful because the data is very small and you can see it with naked eyes. But when you have a very big matrix, maybe it's hard to see, but you can check the dimension and run this one. So you see this is will pop up. Okay, and continue. Okay, this is how you can obtain transfer function in MATLAB when two transfer functions are connected in theory, parallel, and feedback.